Welcome back, everybody. Thanks for being here. Today, we have another DOScember update, another DOScember story. This one is from Dave Brown, who was a former Microsoft employee way back in the DOS days, in the DOS 3.3, 4.0, 5.0 days, and even in the OS2 1.0 days. So we'll talk about all that kind of stuff, and software development, all kinds of other fun things. So stick around. Thanks. Okay, folks, this is Dave, and Dave used to work at Microsoft. Welcome, Dave. What time did you work at Microsoft? What era, year frame were we looking at?
Well, I started there. I interviewed there in December of 1988. I graduated college in 1988, and I had a friend that had gone to Microsoft, and he got me an interview. So I went and interviewed in 1988, and they offered me a job, and I started in January 1989, and I was there from January 1989 until I think about June 1993.
Okay.
So roughly 5 years, a little bit less than 5 years, but 5 years.
Excellent, excellent. So what kind of equipment did they give you, like day one on the job? What were you working with?
I was using. Do you remember the Darth Vader compact boxes?
Yeah.
They were sort of a beige surround with a dark brown front. They looked kind of ominous.
And that was the luggable, or that was just a regular desktop?
No, it was a desktop. It was
Okay.
desktop. It was a 386 desktops. The 386s had just come out. And we all got 386 desktops. And we all used either. During my time there, I used compact machines, I used Dell machines, and I used IBM machines. I used a PS2 there. I needed an extra machine, and there was a cast-off PS2 that they threw. And of course, when I'm saying PS2 now, I don't mean a Sony. I don't mean a PlayStation.
No.
I mean the IBM PS2.
Personal system /2.
Personal system /2, yes, where they introduced their new bus and all that other stuff. IBM felt like they'd made a mistake putting out a generic machine that everybody copied. So they tried to come up with something that was more IBM-like, more specific to IBM, more something they could charge more money for.
Yeah, and that worked out great for them.
Yeah, well, yeah, I hope you're being sarcastic there, because I think that particular line disappeared pretty quickly, and that bus disappeared pretty quickly.
Well, the thing that came out of that was the PS2 ports for the mouse and the keyboard, and the MCA just disappeared.
Yeah, MCA was gone because IDE and EIDE took over. I forget what they're using now, but anyway, it's just that particular bus standard's been around for a very, very long time.
Yeah, and so it's funny that you mentioned they gave you a 386 as your first machine, because looking back in that time frame, it was 8086 and 8088 processors were still very popular, but
they were very popular,
wildly out of date.
Yeah. I had encountered a PCAT in college, running a 286. And the cool thing about the 286 is that you could put it into a 32-bit mode and do some interesting stuff. But you couldn't go back, which was sort of interesting. You would boot in what they called real mode.
Yep.
And then you would flip a bit to go into protected mode, but there was no way to go back, which got in the way of certain things like, so we're talking about ostensibly this whole thing's about MS-DOS, but OS2 plays a fairly big role in this, at least for me personally. But the problem was OS2 wanted to have MS-DOS compatibility, because if you couldn't run MS-DOS, you couldn't run anything, because there was really nothing out there for OS2 yet. So that's compatibility layer. But the problem is that once you've flipped out of real mode, once you've gone into protected mode, you can't go back into real mode. So they discovered, they poked at it and poked at it and poked at it, and discovered that if you hit it with a certain series of interrupts, it would reboot the CPU, and they could get back into real mode. And somebody described it as being akin to driving a Porsche 911 at 100 miles an hour down the freeway, turning it off and turning it back on again. Yep. Without even getting off the road. And it worked, but that was one of the big features of the 386. Among other things, one of the things the 386 could do was flip back into real mode and then back into protected mode, so that they could do it for the DOS box and then come back and do all your 32-bit stuff. 286 was a bit of a kludge, but the 286 was just a moment in time. well, as are all of the processors, but it didn't last long. We went to 386s, and then things stayed pretty solid after that. But yeah, I got a 386. I saw one of the first 486s that came out, and it was running the test of the day was Microsoft Flight Simulator. If you could run Microsoft Flight Simulator, you knew that your PC compatible was actually PC compatible. And I remember the first time I saw it running on a 486, I could not believe that the thing could be as smooth as it was. Do you remember what it was like to get a faster machine?
Oh yeah, because machines back then were like monumental upgrades because you kept it forever. I mean, we came out of this era where your parents had a television set from the 1950s that still worked, and they would pay to repair it.
Yeah.
Into the era of computers where you kept a computer for 5 or more years. And so when you got an upgrade, it was huge. And now it's like, we get one every year, every 2 years, and it's a little faster.
Yeah. Yeah. Well, and you also noticed there's this tendency that once a machine gets fast enough, the software developers all start using that speed.
They catch up, yeah.
And my theory is that there is an established response time. There is an established bit. The human body, I mean, the human mind likes a certain speed. There's like a certain speed of interaction that you get used to, and then if it gets really faster, they throw a whole bunch more stuff at it, and it gets it gets to be just about as fast as it was before. So you spend all of this money to upgrade your machine to get an experience that maybe a little bit more colorful, maybe have a bit more graphics, but feels about as fast as it always did.
Yeah.
It was better for us developers because compilers undeniably ran faster. Being able to compile stuff in half the time made a big difference when it was 40 minutes to do a complete compilation.
And we still have software today that takes 40 minutes or longer to do a complete cycle.
Yeah, well, yeah, and then if you ever explore electronics design, like if you're doing anything with VHDL or Verilog or anything with FPGAs, man, I remember a simple Hello World program. The first time I ran it took 20 minutes to do the layout. Of course, it's odd calling it a program because it's not really a program; it's hardware, but I felt like I was back with Apple Pascal watching the dots slowly crawl across the screen as it went line by line through my code. But yeah, an upgrade was a significant upgrade. And then there was the whole 640K barrier. Everybody had different ways of trying to get around that.
Yep.
Where everybody would have a different way to add extra memory to it. And of course you have to pull out the whole Bill Gates 640K should be enough for everybody quote.
It should be, yeah.
Yeah. I'm not sure that's real. I'm sure somebody can pull out a primary source and find it, but we all say things that we regret. There's a famous quote from the guy who was the head of digital equipment, who basically thought that there was never going to be a need for a computer on the desktop, which is why digital doesn't exist anymore.
Yeah, exactly. So with the Commodore 64, you can still get a lot of brand new, really impressive software that still fits in that 640K, and developers just got better and better.
Now the Commodore 64 is 64K. That's 1/10 of 64.
Right, exactly.
Yeah.
And you know, it's really interesting. The one that I always go back to is the original Space Invaders. You know how at the end of Space Invaders, after you had killed like 9 or 10 of the 12 enemies, it started getting really, really fast, and it was really hard, and it seemed like it was like a difficulty upgrade as the game went on. That was just because there was less stuff moving around on the screen, and the computer could handle it faster. They did nothing to speed it up.
It didn't have to blit as much stuff up on the screen.
Right.
I was going to bring that up if you didn't, but because I think that's just a wonderful little side effect of how sometimes the things that you didn't expect become the most important part.
Yeah,
right.
The game got more difficult as it went on.
Yeah, if Space Invaders didn't ramp up like that, it wouldn't be compelling. You know, I don't know about you, but one of the first things I did when I was learning how to program computers was you find a game and then you nerf the game. You like there was like a breakout game, and I made it so that you couldn't miss the ball. Mm-hmm. And then, of course, it became the most boring game in the world. You know, if there's no ramp up, if there's no risk, it's boring.
Well, people talk about that a lot today. They talk about what's called flow, The game should get progressively harder as your skill set gets progressively better so that you continue to find the game enjoyable. And they've done that very well with not just games in general, but with like cell phone apps. You install a brand new cell phone app, and one of the first things it'll do is sort of walk you through a little tiny, like, click here and type in your name. And you get this guided tour. And by the end of the tour, the whole application's set up, you know how to use it, and you're ready to roll.
Yeah.
And you don't even notice it as much. Whereas before, you would get a machine, you turn it on, and it would say like non-system disk or disk error.
Right.
And then you had a manual that was like this thick, and you had to figure out where to go from there. Oh, you mean I have to put a disk into the machine to turn on the machine to do the thing with the machine? And then when you get that far, it just goes, okay, enter date, enter time, if you're lucky.
Yeah.
And then
Well,
it just drops you out a C prompt, and you still don't know what to do.
Well, even like with the Commodore 64, you turned it on, what'd you get? You got a basic prompt, right?
Ready.
You didn't get something friendly saying insert a disk or do this thing next. You just said, hey, we got this many bytes free, go for it.
Yeah, and it was all up to you.
Yeah, and there was a certain amount of achievement for figuring that
Right.
stuff out. It was interesting in my career, well, in my career with computers, and I'm not talking about what I got paid for, but just in terms of using them. You know, we got the Apple, and same sort of thing. You turn it on, you're looking at a basic prompt, right? If you're lucky, there was a disk and it booted, but you're still looking at a basic prompt. And if you want to do anything, you got to learn how to program.
Right.
You know, either that or throw a bunch of money at software that barely exists at this point, and is going to be a compromise at best. You got to figure out how to do it yourself, and then each step would get a little bit better. And now you've got the things that are appliances. They're toasters now, right?
Yep.
You turn them on, you stick your toast in, your toast pops out, and you go on your day. And literally your toaster probably is a computer now anyway, so it's not really that much of a joke anymore. So yeah, you turn on your Commodore 64. There's one of the advantages of the Commodore 64 was that you knew what hardware you're getting every time. As a software developer, you knew the capabilities of the machines that you were targeting. When things became expandable and customizable, that was really great for us. It really,
As a consumer,
user, we got to use a whole bunch of stuff. But as a developer, oh my God, if I was to write a program that worked on everything, I would have to have. Well, to put this in perspective, in Microsoft, to test the code that we were writing, we would have these rooms that were filled with. I think we had one room that had 500 computers in it, and we were told by the architects that we couldn't put any more in it because we were about to exceed the load limit on the floors. But the whole point is that we'd have all these different brands of machines, and they'd all have different hardware configurations, and you'd have to run your stuff on every one of those machines, because as is true today, the people who install your software and it works fine, they don't say anything.
nope.
It's the one guy in Peoria who has that weird ass video card that you've never seen before, that puts it in and locks up in the machine. He's the guy posting on all the forums. He's the guy calling in all the shows, and he's the guy making all the noise. And now we got to buy some hardware. We got to buy that hardware configuration. Now, to be fair, what we wanted to do was sell software, and if we wanted to sell software, we had to work with your machines,
Right.
and so that was a cost of doing business. And you can't really cry for Microsoft. They've had a little bit of success.
Just a little bit. Yeah, and that's why you get that hardware extraction layer thing. Abstraction, not extraction.
Yes.
Abstraction layer thing. And that makes it so that, I mean, when was the last time you saw a piece of software commercially available that you booted from?
No, yeah, that's true. Well, other than a game.
I mean,
right?
Again, when was the last time you saw that?
Huh. That's true. That's true. That's true. The operating systems now give everybody a way to take over the things like the video and the audio, all those things that you used to have to do all custom.
And it's all kind of virtualized, yeah.
Yeah. DirectX was a huge step forward.
So I mean, that thing you mentioned about the room full of 500 computers for QA testing, if I'm writing a browser-based app, there is a application as a service that exists out in the cloud somewhere that will show me what my app looks like on every single browser, on every single operating system. And it's like $10 a month.
Yeah. The same thing with I ended my career as an iPhone developer, as a mobile developer, and we had the same sort of thing. You could either you had a bunch of different phones with all the different display sizes, or you paid a service that would hook them all up for you and run them for you, and then send you screenshots of what everything looked like. Because I don't care what your design did, it didn't look right on one of them.
Yep.
But yeah, it's the same sort of thing. And well, there's a much bigger infrastructure now than there was. We were making it up as we went along back then.
We still are.
Well, that's true. I've said this to you privately. Anybody who tries to think that we aren't making it up as we go along, and I'm not talking about just with tech, I'm talking about everything. We're making it all up as we go along. Anybody who tries to tell you they know exactly what things are going to happen, they're trying to sell you something.
Yep.
They might be right. They might have a good idea, but we're human. We're stupid. We make mistakes. We're all making this stuff up. We're all taking chances. The only people who aren't getting anywhere.
Right.
If
you're not brushing up against the boundaries, and you're not trying hard enough.
If you're not feeling like you're if you don't feel like you're behind, you're probably not even close to ahead.
Yeah, I mean, if you're racing a car and you've gone through your entire racing career and haven't spun out once, then you're not really racing.
If you haven't wrecked a car. Yeah, it was. I rode dirt bikes when I was growing up, and I remember, the road bike guys were like, "Oh, I've never crashed. I've never crashed." And I'm like, "Well, crap. I've rode dirt. Of course I've crashed. I threw a bike down the road the first time I rode it, And you get used to the mistakes, which is sort of metaphor for life. It's all about the mistakes.
Yeah, and they're only mistakes if you don't really learn from them. So
well, there you go. And speaking of learning from the mistakes, it's sort of the tech industry is sort of a long series of, oh, we'll try this. Oh, that wouldn't work. Oh, let's try this thing over here. Oh, that didn't work. And the strangest things catch on. Who thought Twitter would go anywhere? Right?
Yeah, I mean, like when the guy developed it, I don't even think he thought it was going anywhere. He's like, this is pretty neat. And
yeah, it was.
Here we are now.
Well, it was the Blogger guy, right? It was the same guy that came up with Blogger, and he sort of did Twitter as sort of like, it was a weekend side project. Don't quote me, I'm wrong. I'm sure somebody in the audience will point out exactly how I'm wrong. But the point is that it wasn't his main point. It wasn't his main job. He was doing something else. Twitter was a side project.
Well, it's really funny. If you go online and you look up like how to learn how to program in Ruby tutorial, it's like write Twitter is what you do at the end of your 3-session $15 learn how to program Ruby online class. Is you've now developed Twitter. I mean, you don't have a business model, but you have a working version of Twitter where you can send a message and you can reply to a message and someone else can see the message and so on. So it's like the technology itself isn't deep. It's the business idea that's built on it.
Yeah. Well, and surprisingly enough, you probably built Twitter in exactly the same way that Twitter was originally built, because I believe it was just a Rails project.
Yeah.
So Ruby on Rails, for those of you playing at home. Is that still a thing? Do people still use it?
Oh yeah, all the time. So you had mentioned you got a Compact 386 on your desk.
Compact 386, yes.
And I guess was that the Desk Pro line, or was that something else?
Yeah, I believe it was the Desk Pro line. I'm sure somewhere in there that you could look up a picture of the case and put it up somewhere over here somewhere, because it's a very distinctive case, and it was sort of like, it had a front end like the original Camaro.
Mm-hmm.
That's what it always reminded me of, was that sort of black empty front end.
Which is kind of funny, because if you look back at your photographs from that day, you had the long hair and the electric guitar and the Camaro in the parking lot. So
there you go. Yeah. Now to be fair, I did not have a mullet. I had full long hair. I was not trying to be business in the front.
No, we're talking like 80s hairband hair.
Yeah. It was definitely that. It was definitely a time. Definitely a time. I would have fit in on the Sunset Strip at some point.
So what was like your first project that you had to work on there
at Microsoft?
Yeah.
I was writing test scripts. I was hired there as a software development engineer and test. We were basically writing test scripts that would just test servers at this point. I think I was testing the the file server aspect of LAN manager at the time. And surprisingly enough, file sharing was a secondary application for networks. The primary application for networks was sharing your printer.
It was, yeah.
Because at that point, laser printers were out. They cost thousands of dollars. So you'd buy one for an office, and you'd want everybody to be able to use it. And so the big thing was to be able to share your printer port. That was it.
Printers were so expensive that you would print one copy, and then you would go to the copy room, and there would be this massively large Xerox copy machine. So it was still like desktop printers were still so expensive and so lower quality that it was still worth it to have the big, huge copy room and the staff to maintain that and do the copy jobs and so forth for you.
Oh, absolutely true. At Microsoft, which was at the time, it was still known. This was after we'd gone public. So there were a lot of articles coming out about how much money there was over there. So we were flush, and we still weren't giving printers to everybody. We would have a room full of LaserJet 3s and LaserJet 4s, and the 4P, no, it was the 3P. The 3P would just, man, that was a fast printer. And all the stuff would go there. Nobody had their own printer. And again, we would use LAN Manager, Microsoft LAN Manager. That was the product I worked on. Actually, let me be right back. Oh, well, that didn't. If I'd planned, I had my Ship It award. I don't know if you know what the Ship It award is. It used to be that after you'd ship a product at Microsoft, they would do something special, like when they shipped Presentation Manager 1.0, which was the GUI for OS2.
OS2, yeah.
They flew the entire team to Hawaii.
Wow. And by entire team, how many people are we talking about?
It's like 40 people.
Cool.
It was not a small expense, and the reason I bring that particular one up is because that event caused them to change the policy for how they reward people for shipping software. And what they did is they came up with this award called the Ship It Award, and it was mine was a big lucite block. It was huge. It was heavy. If it hit the ground, people were scared, and you'd get these little sticky plaques on it with the name of the product. So there was in the middle was this thing that said Ship It Award. The highest achievement of a software developer is to ship a product, and then it was signed by Bill Gates. And then you'd have little plaques for all the things that you'd worked on, and I have one. I don't know where it is.
That's how important it is now.
Yeah. Well, exactly. After a while, it was just this big lucite block that was like, I should probably keep this, but I don't know where I'm going to put it.
You're at that stage where you're just feeling guilty for throwing it away.
Yeah,
but back
exactly.
then it was like your whole world. Like, oh my God, I have this thing.
It meant something.
Yep.
Oh my God.
Yep.
Yeah.
I remember jobs like that.
Well, I don't know about you, but until I've actually done something, I think it's amazing. And then when I do it, I'm like, oh, it must not have been so hard because I did it.
Yeah, I have this thing that I say all the time where any benefit once achieved is no longer a benefit. So you go to your first job and they give you like health insurance. Well, your second job better have health insurance.
Exactly.
The first time it's a benefit, the second time it's a requirement.
It's a requirement. Well, that's the human attitude as well. I mean, there's this tendency that if something existed before you knew it existed, you think it's part of the firmament.
Yep.
You expect it to always be there. And then when people go, oh yeah, we got to pay some money to fix it. You're like, what do you mean? It's always been here. Why do I need to fix it?
Yep. And
then the bridge falls and everybody's happy. But anyway, I say that because I am currently being held hostage by a bridge that that they closed because it was about to fail because nobody wanted to pay for it. Anyway.
Well, you'll learn your lesson at one point or another.
Yeah, exactly.
So what did you do for like source code management or, saving all files? You said that you networked printers together, but how did you, share files and stuff like that?
We had this in-house product called SLM, Source Library Manager, which we all referred to as Slime.
Yeah, of course.
And it was simple. There were like three main commands: sync, which was like doing a pull on Git. You'd pull down the new changes. And then there was in and out. The whole idea was out checked out a file, and it did two things. It made sure that it did several things. Among the things that it did, it changed the file from read only to read write. It copied the most recent version, and it would mark that file as locked on the server. So unlike today, where you can have multiple people working on a single file at the same time, and then the software usually merges the changes badly. We won't go into that. It just wouldn't let anybody else change it. It just wouldn't let anybody else change it. You'd check it out, make your changes, check it in. That would copy it back up to the server, and then set it read only on your machine so you don't mess it up again, and then unlock it on the server.
So you'd never have to rebase.
There was never any rebases. There was never any merging. If there was, it was usually because somebody was doing something wrong. Although people would argue that using it at all was wrong. We had source library management for source code management. We had a product that we called RAID, another internally developed product we called RAID to track bugs, stuff like that.
I see what you did there.
Yeah, and well, it's what everybody did. Developers drove their task lists from RAID, just like they do today. Only now it's Jira, and Jira looks like RAID gone mad, is what it looks like.
Yes.
So I think they still have something internally they call RAID, but it's not at all what it used to be. And then I remembered we went to for source code management. They had a project internally called Delta. I think that also made it out into the world at some point. And now it's whatever they do in Visual Studio. IDEs kind of became a thing as I was leaving Microsoft.
Right.
In the last couple of years I was Microsoft, Visual Basic came out, Visual Studio came out. We were moving compilers from command line things to IDE things,
So I got a copy of Turbo Pascal 6 in the early 90s. And it was really wild to me to I had a hard time wrapping my brain around this metaphor. This was when object-oriented computing just kind of launched onto the scene. And the IDE was developed in Pascal,
right,
using the library framework that Borland had provided for you to write code in. It's like they wrote the code in the thing they wrote the code in.
Yep.
It was like
they ate their own dog food.
It was this self-recursive weirdness thing, and it really wasn't all that pretty. I mean, it had all the file drop-down menus that you'd expect, and it had the windowing interface, and this was all text-based. But the color scheme that they chose was just awful.
It was a programmer-designed UI.
I mean, so hey, look, we can use color. Let's use all the color we possibly can.
Yeah, let's show the world that we actually have color now.
Yeah.
Because if we just do black and white, people aren't going to know.
Yeah, and now we're fighting for dark themed things that removes a lot of color. I mean, it took so long to stop blasting white at your eyeballs all day long.
Well, and how about the change from I can show 16 colors, I can show 8 colors, to now it's just it's 24-bit.
Yep.
24-bit color depth, true images. It's just, anyway, it's amazing what we can do today.
Yeah. And you can still take a 24-bit image and shrink it down to a small color palette and not even really notice a change until you start zooming in on the nuances.
Oh yeah. Or you get you flatten the color palette, and then for somebody like me, it looks like, oh, look at that. That's better than the picture I had on my Apple back then. Everything looked better than that. Anyway, I think I'm dead ending on this one.
Yeah.
Where do we want to go from here?
Yeah, so we were talking about DOS. What version of DOS did you get when you had that first machine?
Well, you were booting. You were either booting an internal version of DOS 3.3, or you were booting OS/2 something. And a lot of people used OS/2 1.0 because it looked just like DOS. But yeah, we were using mostly 3.x internally because 4.0 was a strange thing. I think if you go look it up on Wikipedia, they say things like it was rewritten by IBM and it had a lot of compatibility problems, and that's a pretty good description of it.
Yeah.
And then 5.0 was sort of like when Microsoft took it and stripped out all the excess cruft that IBM put in. And you're going to install it. You're going to see it.
Yeah. And I don't think I've ever actually ran it. I was thinking back to myself, there was this time where everybody used to tell you not to get the .0 release. Always wait for the upgrade. So I looked out in the archives, and there's 4.0 and there's 4.01. And then when DOS 5.0 came out, they said the same thing, like don't get the .0 release. But this one's better. This one's fine. And I don't think there was any. I think it was 4, 4.01, 5, and then 6. I don't think there was
there weren't a lot of
5.0
versions.
and 6.
Yeah. And yeah, the big change for 4.0 was IBM grabbed 3.0. And internally, the biggest change was they changed the language it was written in. It was just Microsoft Assembler. 3.3 was almost completely MASM. And IBM had developed this internal development language that was like a macro assembler on steroids that it added a bunch of stuff in there. So it looked like a completely structured language, which you would think would be a good thing. And it made it really easy to write code. And the problem with making it really easy to write code is you end up writing a lot of code.
Yes.
And that may sound like a good thing. If you're an application developer, that's a really good thing.
Well, we can get into the whole K-lock conversation.
Huh?
We can get into the whole
K-lock
conversation.
But before we get there, let's look at the point of view of an operating system. An operating system has to do what it needs to do and get out of the way as fast as possible. Because if you're slow in the operating system, you're slow everywhere.
Yes.
So the operating system has to be the quickest, smallest, least impactful code, which is kind of funny because it's also the most impactful code because it lets you use the hardware on the machine. And that's the whole point. Like, you want to be able to use the hardware on your machine. So IBM created this language that made it real easy to write a lot of code. So they wrote a lot of code. So suddenly this operating system used a lot more RAM, used a lot more clock cycles, and you got everything slowed down. You couldn't load as much stuff. Things were incompatible, but you got more features. Woohoo, more features, but features that nobody used, because one of the first things a lot of people would do is they'd back down to DOS 3.3 and continue running their own stuff.
Yep.
And I got to tell you, as a professional developer, I've been fighting this battle my entire career, which is, it's not your computer.
Right.
It's not your RAM. It's not your disk space. It's the guy who owns the machine's disk space. And if you use it all up so that he can't use it, your program's going to get uninstalled, right? I used to tell people when I was doing mobile development that it's like, if your phone gets hot every time they run your app, they're going to stop running your app.
They're going to notice, yeah.
Yeah, if the battery flatlines every time they run your stuff, they're going to stop running your stuff. And the reason the stuff's flatlining is because you wrote all this extra code you don't need to write. You wrote it inefficiently. You're using too much RAM, and nobody wants to use your stuff now. Which, now I'm going into a more general rant. If we go back to it,
one rant at a time, Dave.
Yeah. The big problem with DOS 4.0 was it was more complex than it needed to be on something that didn't give you enough benefit. Windows gave you a benefit. At least Windows 3 did. None of the Windows up to that point did. But Windows 3 gave you a benefit. You got something for the additional resources it used. But you didn't really get anything for the additional resources that DOS 4.0 used. DOS 4.0 existed because IBM wanted to make a version.
So what was the name of this language at IBM?
You know, I knew you were going to ask that, and I cannot remember. For the life of me, I cannot remember.
It was just that hard that it never took off, and it's not even a name anymore. Yeah, it makes sense.
Well, my encounter with it was, I was working on this project where, once again, hundreds of test machines, right? And they would have kernel debuggers on them. And the thing about the kernel debugger is that its interface was through the serial port. It wouldn't go through the screen, because the whole idea is you're working on stuff that may have UI problems, and you can't use the UI to
Yep.
debug the UI, so you go through the kernel debugger. So we would have all these machines. We would have one machine with a bunch of serial port cards, a bunch of multiple serial port cards, and then we would run a line to every one of the test machines. So you'd have these groups of test machines with one machine that was monitoring all of the serial ports, and would figure out when something had fallen into the kernel debugger, and it would figure out who was running what test on that machine. It would send email to the person who would share the serial port. You could sit there and debug from your own machine, which was all brand new stuff. I actually got a bonus for that. Now it's common. But so I ran into it because we needed to be able to remotely upgrade operating systems. So I needed to be able to write a boot sector. I needed to be able to write a boot disk. And the easiest way to do that was a sys command, which you encountered, I think, in one of your previous episodes. And so I wanted to take the sys command and modify it to produce a boot sector of my own design that we could use to then remotely reboot and do other stuff. And so I'd asked to see the source code. I had asked for access to the source code of the most recent shipping version, which was 4.0. And I had this brand new 300 meg hard drive, which was huge. It was enormous back then. It was the special thing. And I couldn't fit the source tree on it. I couldn't get all of it. And so I went and I downloaded just the part that I was interested in, the sys command. And it was incomprehensible. It was just this weird language that was much bigger than it needed to be. And so I then went and asked for access to DOS 3, and I got access to the source code of DOS 3, and I believe I got the entire source tree down in 10 megs.
I wouldn't doubt it.
Yeah, and that was what I went forward on. I modified the boot sector so that it would so that I could remotely reboot it and remotely install new operating systems. And let me tell you, when you screw that one up, that's an interesting effect. I remember convincing my PS2 that its hard drive was actually a 1.44 megabyte disk because I'd accidentally copied the boot sector of a floppy onto the hard drive. Anyway, so my encounter for that was my encounter for DOS 4.0. It was as the stories you've probably heard go, most people install it and then would back out, or they would install it and they went to 5.0 as soon as they possibly could.
I think I'm getting some feedback.
Huh?
I'm getting an echo from your side.
I wouldn't be surprised.
Then it all went away. All right, we'll cut that out. We'll just keep right on going.
Yeah, because computers.
This is so much better when it's not live. There's so many more things that go wrong.
Well, yeah, but it ends up looking a lot smoother than it did.
Oh, I don't know that I'm going to change it all that much. There's too much good
stuff. Where do you want to go now?
So you were talking about, yeah, we'll just go back to the Klocks thing.
Right. Oh, yeah, the Klocks. The lesson, first off, for those of you playing along at home, KLOC is KLOC, stands for 1,000 lines of code. And the idea was that IBM decided to measure programmer productivity by how many Klocks they produced. Any of you developers listening nowadays know immediately what the problem with that is. And it sort of goes back to the Dilbert cartoon where the boss decides he's going to reward people for how many bugs they find.
They find lots of bugs. They start making bugs.
Yeah, you partner with a developer, right? And then you split the proceeds. It's like, you tell me where you put the bugs, I'll file them, and then we'll both split the bonus. The answer is you get what you reward. Yep. And so when you are rewarding people for how many lines of code to produce, they produce a lot of lines of code, and it's not all good. And to refer back to what I was talking about earlier, you don't want to be the guy in the operating system making huge things. And it seemed like what DOS 4.0 was the ultimate argument against KLOC as a measurement of performance, because it was huge. There were a large number of KLOCs in that code. And also, any good developer will tell you that you can go in and end up with a net number of lines of code produced of 0 and still made a large difference. You can go negative and you can still make a large difference.
That's one of the things that I struggle with now is, we do this story pointing thing. and you get like a story that's going to work out, whatever your point system is, because point systems are different in every company. You get a story that's going to work out to be like 3 days worth of work, and you're working your butt off, you're trying to get to the answer, you're scratching your head, you're in deep, and it winds up coming back at 4 days, and you get it all polished up and you turn it in at the nth hour on the 4th day, and what you've turned in is like 7 or 8 lines of code.
Yeah.
And everybody knows you worked really hard to get that 7 or 8 lines of code out, but it's like, man, for 4 days worth of work, I want like, I don't know, an even 1,000, 500 lines of code. I mean, like, you used to be graded in elementary school by your 100-word essays, and you were struggling to get 100 words out. And now it's like, I did 7 lines of code, and a lot of that was just copy and paste.
Yeah. Well, the other side of that, I would spend 3 weeks tracking down a bug that turned out to be a 1-line change.
Yep.
And people would laud me for this, like, but I'd feel like I just spent 3 weeks to change 1 line of code.
Yep.
Right. Now it took me 30 years of experience to figure out which line of code to change. And my experience is that it's the small fixes that take the longest to find.
Yep.
If it's a big fix, it's obvious. And it's like, oh, look, there's a whole bunch of code that hasn't been written that needs to be written. So you do it.
Yep.
But, and today, with all of these new tools, like these languages that prevent you from making all these other mistakes, once they've gotten rid of all of the easy mistakes, all that's left are the hard mistakes.
Well, my favorite thing, going back to the early versions of Windows 3.0 was the one that was really popular.
Yeah, it was the only one it was the first one that people actually bought.
Yeah, and Windows 3.0, I'm not sure. I'm probably going to get it wrong. There was a UAE error and there was a GPF error. I'm not sure which one came first, but it was the big thing in all of the reviews and all the magazines, and everybody was talking about it. Like, all this thing ever does is put out this error message. And then they came out with Windows 3.1, which fixed that problem and gave you the other error message. And I always looked at it and I went, so you mean they spent all that time to remove error message 1 to substitute it for error message 2? Because as an end user, I'm still experiencing the same number of error messages all day long.
Right. And the error you're seeing is
We didn't know what to call it. Yeah.
Well, in internal from being internal to Microsoft, the problem that was hardware problems. That was people using strange little hardware things or driver issues. Drivers drove us nuts because drivers have access to the internals of the operating system, but they weren't written by you, and they didn't get access to all of the documentation that they may or may not have needed to do it right, and so they died. Video drivers were infamous for that. And it's really hard to from a user point of view, you're exactly right. The way you described that, from a developer on the other side of that, all I can do is get a really sour look on my face and go, that's not really what was going on. But I understand exactly why you're talking about like that. And in the end, we want you to give us money. So it really, your point of view is the only one that matters. And if that's the impression you're getting, that's the impression we got to fix, And so it meant a lot of hack code. You would not believe the amount of code in Windows that was there just to work around bugs with existing drivers.
You guys are just fighting it out with each other quietly, very passive aggressively.
Oh yeah, there was this internal behind the scenes war of all the other of all the driver manufacturers, all the hardware manufacturers, that the public never knew anything about. It was this, being in the business was interesting because there's the business as I know it, then there's the business as it's covered in the tech press, then there's the business as it's covered in the popular press, and then there's the things that your friends who know you are a developer complain to you about. Right. Like, I used to hate telling people I worked at Microsoft because the first thing that would happen is I would get a litany of bugs I needed to fix on a product that I had nothing to do with.
Oh, you fix computers. There goes every holiday.
Oh yeah. Yeah. No,
son, it's so great to see you. Merry Christmas. Come over here. Look at my computer.
Fix this.
Yeah.
I was amused at the modern trend of around Thanksgiving where these articles would get published about, have these fixes ready because these are the things that your parents are going to have had problems with.
Nice.
But yeah, we got the errors. I remember was it Windows 3.1.1 was the ultimate version
Was.
of Windows. Windows for workgroups. Windows for workgroups. 3.1 was a huge. 3.1 introduced TrueType, which caused us no end of problems. One of the easiest ways to crash Windows was to resize a font.
Which seems, like you said earlier, it seems so elementary. Like we do
Yeah.
this 90 times a day and take it completely for granted.
Right. You know, because if you resized it to a font it didn't have, it'd have to regenerate all the bin images, and then it would go out to lunch, and then it would die. And then 3.1 built networking into it, and that was actually, I think, the last Microsoft operating system to ship without a network. Was
Yep.
Microsoft Windows.
Yep.
And then 95 came out, and blah blah blah. So back to DOS. I don't know why I said that, other than to get us back on track for some reason.
Why would we ever want to stay on track?
It's ostensibly a video on you installing DOS 4.0.
Yeah.
So perhaps we should talk a little bit about installing DOS 4.0.
Yeah, so in the series on the channel, that's where I'm headed next. I did the Microsoft released the source code for DOS 1.25 and 2.11.
I saw that. I saw that.
I installed
they put it up on GitHub.
Yeah, so I installed DOS 1.25 and it pretty much did nothing. I mean, no hard disk support.
Right.
I'd have to go back.
Well, 1.0 was essentially CPM. 1.0 was basically getting something that looked like CPM to work on to work on the 8086.
Yeah.
Have you gone into why the C drive is the C drive?
No.
Do you know ahead. Why the C drive is the C drive, don't you?
You tell it. You're the insider.
Okay. Well, CPM. This all dates back to CPM. CPM came out in the mid 70s. It was actually one of the first operating systems. Somebody, again, is going to prove me wrong on this one, but I'm going to say it is among the first operating systems to use a hardware abstraction layer, which is what made it popular, because everybody was building these these bespoke 8080 systems.
Yep.
You know,
they
all had the F100 bus, but everybody had a different set of cards. And so you rewrite the hardware abstraction layer to support your machine, and now you can run CPM. Well, CPM needed a way to differentiate which disk was in what drive, so it gave them all letters. Mm-hmm. So the first disk was A, the second disk was B, and so on. And it was very common to have two disk drives, two floppy disk drives, and those became A and B. And it was, some people had more drives than that, but two was pretty much what everybody had, because two allowed you to copy floppies without swapping them back and forth.
Yeah, the original PC supported 4 floppies.
Yeah, and you'd have your program floppy in one, and you'd have your data floppy in the other, right? When hard drives came out, they were generally the third drive, which gave them the letter C. And that's it. That's simply it, because when hard drives became the main thing, everybody was already used to calling their hard drive C. It would have made sense to me that it became A because it was the first drive on the machine.
Yep.
But because developers do easy things, they just assumed that if it was coming from the hard drive, it was coming from C. Most of the things that we run into have to do with lazy programmers.
Yeah, and so
you hardwired something.
You were asking about this story, and it's like, that's it, folks. There really isn't any deeper. There's no hidden meaning. There's no metaphors. You know, a bunch of people didn't get together in a room and do it. Somebody sat at their keyboard and said, "I need another drive letter. I guess it's going to be C." It's like, why did they call it the C programming language? Because there already was a B programming language.
because there was a B and a BCPL, and they called it C. Yeah. Yep. And I remember, well, it's like C sharp. C sharp came from, the whole idea was C++ with another plus plus over the C, and when you over the other plus plus, and when you put them all together, it looks like a sharp.
Yep.
But the whole idea, it started off as an improvement on C++, and then that project died, and then it became what it is now, which was basically Java from Microsoft.
Yeah, and there's like a F language too, isn't there?
There's an F, which is the functional programming language. I don't think it has to do with the fact that there was an E. I think it had to do with the fact that it was a functional programming language. There's an F sharp as well, isn't there?
I think so.
Yeah.
Yeah, I didn't go down the application development path very long, because all of those potential bugs would have kept me up all night long. So I just stayed away from it.
Yeah. Now I actually want to, I make the joke about lazy developers, and let me put some perspective on that. A lot of things that make lazy developers, well, they're not lazy developers. Generally what happened is a deadline occurred.
Mhm.
There was some pressure to ship something regardless.
Or a price point.
And yeah, and us developers, we're trying to make things as flexible as possible. We'd love to make it so you could put in whatever drive letter you wanted and have it work. But my boss said that this $1 million deal ain't going to go through unless we ship on this date.
Yep.
So do whatever you need to do to get this out the door. And so you hardwire the drive letter, and everything's there. Sort of like the rumors I've heard about why there is no Windows 9.
Yeah, because Windows 95 and 98 existed, and everybody would think they would immediately be going back in time from Windows 8 back to Windows 95.
They'd look for the 9. They wouldn't look for specifically Windows 95 or Windows 98 or heaven forbid, call the actual operating system entry point to find out what version you're running.
Yeah, just ask.
You know, which it's surprising how many people just never did that. You know, they just, oh, I know I'm on this, so I'm going to hardwire it and we're going to ship it and everybody will be happy and I get my bonus.
Yeah.
And then I retire and I don't care anymore.
It's really funny how it's super easy to ask stupid questions, but it's unbelievably difficult to ask the actual real hard questions.
Yeah, it is. It is. And again, the people that are giving us the money, they're asking the stupid questions, so we're going to deal with giving them the right answers to the questions they're asking. So
sometimes that's all it takes. So you mentioned OS2 1.0 being very DOS-like, and I don't remember the first version of OS2 that I used. I know OS2 Warp 4 was the big boy and kind of the last one. I think there's an independent group that's moved it farther forward than that, or at least updated it.
I think there was, but I kind of lost track of OS2 after it left Microsoft, because the only reason I was ever using OS2 was because I was working at Microsoft, and developing code on a protected operating system is a lot more fun than developing code on an unprotected operating system, because a bug in your code in an unprotected operating system would crash the machine. You know, I don't know how many times you'd have a bad pointer and it would just spray data all through memory, you know, like into the video memory. Suddenly it would look like Walt Disney threw up on your screen, and then it would lock up and then reboot, you know, and all your work would be gone.
Yeah, and to me that was kind of a byproduct of programming in C. I don't know if assembly did that or not, but in C you would initialize a pointer and it would just be like, here's your pointer. And it didn't actually empty the memory contents.
No, it didn't. And assembly was worse. Assembly didn't care. If you told it to do something, it did it, whether it was the right thing to do or not. And yeah, you had to worry about, well, and you had to worry about initializing your memory. You had to worry about not exceeding the bounds of the memory you allocated to that memory. I had a bug that I'd written myself that had to do with the fact that I was writing 4 bytes into a struct that the particular field only needed 2. And so I was overflowing into the next one, and then everything would crash because the next person that looked at the value after it got the wrong value and it would blow up. Yeah, it was programming without a net. And if you didn't know how to program without a net, you weren't a developer.
And all those things still exist today.
Yeah. And I'm not saying that as sort of like real developers or I'm a hard ass about that. It's just there wasn't anything else. If you wanted to do this for a living, that was the environment you were in.
Yeah, you get the job done today, and then tomorrow you realize that there was a mistake that you made yesterday. And we've embraced that a lot better than we did in the past. I mean, in the very beginning, you were expected to know inside and out what to do, and your job was on the line if you screwed up. And today, we've sort of eased up on that, because I go into a lot of jobs, and what's happening is we've developed our own software here.
Right.
And there's no way you can be an expert in any of it because we made it. So we just want you to have a good skill set and then, you know, kind of be well-rounded. But everybody else, everywhere else is also developing right now, right here in real time. And we're all working in real time. Like, you know, my first job, I needed to know Windows 3.1 inside and out because it existed. And today, Windows 3.1 would have been Windows 3.1. Monday morning.
Right.
And then it would have been 3.1. Tuesday afternoon. And then it would have been 3.1. Wednesday. And if you're catching on to the metaphor there. And so
Oh, yeah.
I didn't need to be an expert anymore. I needed to be agile. And that's where that whole agile methodology thing comes from. And, it's better than it used to be.
Well, I feel like Agile was admitting that we don't get it right the first time.
Mm-hmm.
And we might not even get it right the second time.
Right.
But if we keep pounding on it, eventually we'll get somewhere close to what correct is. I once told somebody, software doesn't ship at the keyboard. Software ships in meeting rooms where you decide to deprioritize bugs and what you're willing to live with. Right.
Yeah, we got to get it out the door. That's my favorite thing. Like, you walk into your favorite big box store and you look at the price of a refrigerator, and it wasn't, $398.88 wasn't the price point that they came up with in the meeting room. It was they tried to get as close to the $400 target, and that was where they landed.
Yeah, that's exactly right.
And then when you're in a store like Walmart, when you see that 88 cents, that means that product's going to be gone next week and never to return.
That's true. You can tell a lot from the prices at Walmart.
Yeah.
But people don't realize that it's never as simple as you think to add a particular feature, because you're not. Let's say I worked at another company on a particular feature that you want to add to your code, so you hire me to do it. But what you don't realize is that the feature I did over there had the context of all the code that was there. It worked. I was able to get it done because of the way all of the other stuff had been done previously. And I come into this new source code repository, and I'm looking at the code, and it's like, for you to have that particular feature, you would have to rewrite the firmament. You would have to change the basis of the way your code works. And I don't think you can afford me for doing that, because we're talking about 6 months. And even then it may not ship. And you don't want that. You're paying me money because you want to hear an answer. You want it to ship.
Yep.
And so I'm going to end up hardwiring something.
And I've been on projects where they've changed the definition of done so they could meet a shipping date. Yeah.
Oh, all the time. Again, software ships in the meeting rooms. Software ships because executives decided to shove it out the door, not because it's done. I've found out that they shipped my code 2 weeks ago. Right? I'm like actively working on stuff, and it's like, oh no, we sent that back 2 weeks ago. Like, but it still had this bug. What do you mean?
It's not done yet.
Yeah.
And if those executives didn't make those decisions, we wouldn't be where we are today. So I mean, everything in life is a compromise, and you have to get past the saying is, don't let perfect be the enemy of good.
Right.
Like, I'm never going to have a perfect car. It's not going to exist. But I still need to get to work every day, and therefore I have this car.
Right. Exactly.
And it is good.
all of life is a compromise, unfortunately.
Yep.
It's like, it doesn't matter how good of a developer I am. If nobody's buying the code, if nobody's buying the product that I'm working on, I'm not going to get paid. I
mean, that's a good example of the CPM versus DOS story in the first place, because Gary Kildall wanted to charge, like, I want to say $200 for CPM, and Microsoft wanted to charge like $50 for DOS.
Right. Well, $50 with a virus installed. And I don't mean a software virus. I mean the legal virus. The fact that the fact that they were able to get IBM to agree to allow them to sell this to other people.
Yep.
I think it was IBM always got it first, and then they sprinkled some special sauce on it and called it PC DOS.
Yep.
But eventually even that went away, and it was all MS-DOS all the way down. But
I think Microsoft stopped releasing DOS, and IBM kept going for another year or two. Like, there's PC DOS 7, but there's not Microsoft DOS 7 or something like that.
Oh, there's
free DOS.
There are still some contracts, usually involving government agencies, to maintain versions of that. Like, I just saw, God, I forget what article I was reading the other day, but it showed a picture of some Navy guy using some food inventory program that was running on DOS, and it was still running.
Well, I mean, so we recently ran into that with all the Cobalt programmers coming out of retirement for the HR stuff surrounding the coronavirus. All the
Huh.
unemployment stuff.
I thought you were, it's funny because the last time that happened was Y2K, and that was a bit ago.
Yeah, we hadn't learned our lesson yet. 20 years
Yeah,
later.
yeah. But well, COBOL is a virus that's never going to go away. You can make the argument that COBOL is the most successful programming language that has ever existed
It
because it's
is.
still here.
Yes. Windows
It may
XP is the
be.
most successful version of Windows.
Yeah. There you go.
All your ATMs and cash registers.
Yep. 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 And well, and I think of C as the assembly language of everything now.
Yeah.
It's like it's sort of the base language for everything.
Yeah, nothing goes below that, hardly at all.
Yeah. So where are we?
I think we're coming to the end.
Well, I just give you the material. You do whatever you want with it, man.
Yeah, I'm an hour into recording. I think we have plenty here for a good 30-minute show. Yeah, we had to cut this one short at the end here, but if you like this story and other DOScember stories, search for the hashtag DOScember or leave a comment down below and see if we can get Dave back on the channel. Dave's been on the channel once before for a ham radio related interview. I'll leave a link to that one right up there, and you can take a look at that if you want to see how Dave does his ham radio, and he actually did a lot of space content for that interview. So thanks for being awesome. We'll see you in the next one.